We saw an exercise that required this already, but now we state it formally. So if we look at the formula, we have log base a of a to the x is the same as a to the log base a of x, which is just x. So another way of saying this is that log base a undoes a to the x and vice versa. So just as a short example, if I have, let's say, 3 to the log base 3 of, I don't know, let's say 4, this is the same as log base 3 of 3 to the 4, and it's just 4. So whenever you see an exponential together with a logarithm and they have the same number associated with them, they're typically going to undo each other. So you want to look for that pattern when solving these problems. And in fact, we can see this sort of inverse relationship between exponentials and logarithms if we look at the plot of a logarithm. So here I've plotted y equals log base 10 of x. So it's maybe a little tricky to see, but we can put some points on here. Right? At 1, my value is 0. So 1, 0 is on this plot. So y equals log base 10 of x. So at x equals 1, y has the value 0. Are there any other points we can plot easily? Well, at x equals 10, this is the value 1. 10, 1 is on the plot. And in fact, if we had lots of time and energy, we could draw this plot all the way out to x equals 100. And then what is the value of the logarithm base 10 at 100? Only 2. We saw this exercise already. So what is that saying? In other words, logarithms grow very slowly. Right? Compared to exponentials that were sort of growing very, very rapidly. And indeed, it's somehow nice, I think, to, this is a very precise sketch here. I used a computer program to generate this for me, but it's nice to have a mental picture of logarithms as well. They look something like this, whereas the exponential function looks something like this. Okay, so you can somehow think of them as almost like they're following very similar patterns, but in different ways, right? So this would be logarithm, and this would be something like a to the x. Okay, so they really are quite similar. And just as a remark, computing something like log base 10 of 7 is very difficult. Most numbers are very hard to compute logarithms of. They're in fact examples of what are sometimes called irrational numbers. We'll discuss this in Module 4. But in particular, you in general have no hope of computing these. You can use computer programs to do it very quickly. And in fact, before computers existed, idiot savants would sit down and compute these numbers all day long to fill books for engineers to use for their projects. So don't feel bad if you can't quite understand exactly how to compute different logarithms. It's very, very specific when you can do it. But what you should understand is the general sketch of them and how to plot a few points, like over here. And this should take you very far, at least for the level that you need to understand logarithms for the CLEP exam.